Welcome to the Labflow workshop. We are going to study the second experiment in Labflow, which is identification of a halide. Can you hear me? If you have any questions or if you cannot hear, you can always raise your hand at the lowest part of the screen, or you can message me and stop me anytime that you have a question. So as I said, halogens are in the main group 7 in the periodic table. And these elements are fluorine, chlorine, bromine, iodine, and astatine. And we said that this is the main group 7 in the periodic table. Astatine is the heaviest halogen. It's the last element in group 7. And it is very unstable and radioactive. So we will not study astatine in this lab. We will only do qualitative analysis for these 4 halides. Why do we say halides? These halogens do not exist free in nature. The free element exists as diatomic molecules. What does that mean? That the fluor is going to be fluor 2. Basically, each molecule has 2 atoms. And basically, these 2 atoms form a covalent bond sharing 2 electrons. But we said that these halogens are very reactive. We don't find them in nature like diatomic molecules. And in nature, we found these halogens as salt. And they are found as ions in the form of -1 charge. So we find the fluor as fluoride, chloride, bromide, and iodide. Those are called halides. The end is IDE. They have a -1 charge. And what are we doing? This is a very simple experiment. You should get the maximum amount of points because we are only going to test these 4 halides and do a qualitative analysis on these halides. So all this experiment is about 2 main reactions. So here in the write-up that you see, we are going to perform 2 main reactions and observe. This is again like the first experiment, is qualitative analysis. We are going to add in the tube some reagent and look for a sign for a change in color or for a form of a gas or cloudiness or a precipitate, whatever change can let us identify the halide. So basically, in order to identify these 4 halides, we are going to perform 2 main reactions. Here is the first main reaction, this one. What are you going to do? You are going to prepare 5 test tubes. 1, 2, 3, 4, and 5. What are you going to put in each test? You're going to label. In 1, you are going to have the solution of your halide. So in 1, you're going to add 4 mL of the salt of fluoride. And it's going to be a solution, a clear solution, that is 0.2 molar. So basically, tube number 1 will have fluoride. Tube number 2 will have chloride. Tube number 3 will have bromide. Tube number 4 will have iodide. And tube number 5 will have your unknown. So basically, your unknown is going to be one of these 4. Your unknown is going to be either fluoride or chloride or bromide or iodide. And depending on the color of the tube, you are going to recognize what halide do you have. So the first thing you do is you prepare those 5 tubes, as I said, with these 4 halides that you are going to test. In 1 tube, fluoride, chloride, bromide, iodide, and the other, your unknown. And then what do? You add to the 5 tubes, you add 2 drops of silver nitrate. There are not many reactions to remember, so this one you should remember. Silver nitrate is soluble. It's a solution. What does it mean it's soluble? In Chem 2, you know it's a clear solution. If it's insoluble, it's going to be like if you put sand in water. You're going to have a precipitate, a solid. So in this case, silver nitrate is a solution. So we are going to add 2 drops of 0.1 molar silver nitrate to each of the 5 tubes. And what is going to happen? Here, here it says aqueous. So silver nitrate, like it's a liquid, a clear solution, you add it when it says sodium X. X can be either of the 4 halides. X can be fluoride, or X can be chloride, X can be, they don't want to write it 4 times, so they write an X. And it says here, 3 of the 4 halides form an insoluble salt with silver. That means when you add the 2 drops of silver nitrate, the fluoride is not going to form any precipitate. Clear, nothing, no reaction, because this salt with the fluor is soluble. But all the rest will form an insoluble salt. So we are going to have in this reaction, if X is chloride, this is going to be silver chloride, and we write it with an S, which means solid. Don't confuse with soluble. S is a solid. So basically, you have a salt that is solid. So if the precipitate is, if the halide is bromide, you are going to have a solid salt, which is silver bromide, also solid. And if it's iodide, you are going to have a solid that is silver iodide. Now, how are you going to recognize? You already know that if it's fluor, you won't have any solid. But if you have a solid, you will look at the color. There is not much difference, but this one, they will give you that data. So if you have chloride, the precipitate is white. If you have bromide, it's going to be kind of whitish, but not that white, like a off-white. And if you have silver iodide, it's going to be kind of a yellow precipitate. So this is the first thing. And then you're going to do with your unknown, and you will look which one of the 4 is. So you will have your first idea. Okay, my unknown can be chloride or fluoride. And there is another thing that you are going to do. Once you have the precipitate, either one, it can be any of these 3, you will add to the precipitate ammonia. And the precipitate is unstable in ammonia because it forms this stable complex and dissolves the precipitate. But another key, another thing that you are going to observe is how many drops of ammonia you are going to count. How many drops of ammonia you need to add in order to dissolve the precipitate. So let's say you have this one, silver chloride. You might need about 15 drops. If you have silver bromide, you continue add, and you might need 25 drops of ammonia until you dissolve the precipitate. Here it says AQ, that means is aqueous, is you dissolve the precipitate. This solid precipitate is dissolved with ammonia. And if you have, let's say, you added 60 drops and you didn't dissolve it, then you're gonna say 60 plus, and you know it's silver iodide. So this is the first reaction, and this experiment is very simple because you are going to do only 2 sets. Enjoy and get the maximum grade with this experiment, because the next one is very time consuming. We'll talk about that later. So make sure you get the maximum point in this one. Now, this is the first set of the reactions. We said we have the 5 tubes and we add the silver nitrate that is soluble, and then once we have the precipitate, we dissolve it with ammonia. Then here it says the next test to make sure which of the halogens you have is to perform the halides reaction with chlorine water. What kind of reaction is that? Again, you will have 5 tubes. 1, 2, 3, 4, 5. Again, one is your unknown and the other is with each of the halides: fluoride, chloride, bromide, and iodine. And then what do you do in this second experiment? You are going to add, once you add the different halides, you are going to add mineral oil. I will explain very soon. So you will have, this is aqueous, and then you are going to add mineral oil. You know that the mineral oil and water, the oil and water, they don't mix. They form 2 phases. So you will have one phase of the mineral oil and the aqueous phase. The mineral oil, you will look at the color, has no color. So you are preparing the sample. So you have your halides, you add the mineral oil. Once the 2 layers are ready, you are going to add to all of these tubes 2 ml of Cl2. You are going to add chlorine water to each test tube. This is the second test. And then what is going to happen? Let's look at the reaction here. You have the chlorine water. And it reacts with the halides. And it is a redox reaction. So let's understand what is going to happen. Chlorine water is basically chlorine gas dissolved in water. Chlorine water is an oxidizing agent. Remember that. Chlorine water is an oxidizing agent. So it will reduce any halides that are stronger reducing agents. I know this sounds a little confusing, but it is not. When is this reaction going to happen? Let's look at the oxidation state of this. If somebody can tell me, chlorine water, its elemental state, what is the oxidation state of chlorine water? It's elemental. When you have an element, what is the oxidation state of an element? 0. What is the oxidation state on the product side? What happened with the chlorine water? it was reduced. Here, what do we have? A sodium and a chloride, right? The chloride has a -1, so the oxidation state is -1. So if the chloride went from 0 to -1, it went to a lower number, from 0 to -1, which means that the chlorine water was reduced. So the chlorine water was reduced. If the chlorine water was reduced, the other halide has to be oxidized, right? Let's look at the halide here. It's a -1 to an elemental 0. So here it was oxidized. One is always reduced and the other is oxidized. So when the chloride is reduced, what do we say? We say that it's a
Oxidizing agent.
yes. Awesome, Yvonne. Thank you. Exactly. And this is something that you're going to encounter. So it's good that you need to understand. If not, you can ask me, anybody, because this is, they will ask you in the quiz, they will ask you in different parts. So it's something it has to be clear. So because the chlorine water is reduced, Yvonne said it's an oxidizing agent. Very good. So now, which are the halogens that are going? We said that we have 5 tubes, right? We have fluoride, chloride, bromide, iodine, and our unknown. So which one are going to be oxidized? Usually you have the periodic table. You have fluoride, chloride, in this order, bromide, iodine. The chloride is here. It will oxidize as you go down the ones that are down. So basically, it will oxidize the bromide to bromine and the iodide to iodine. Because, as I said before, it will reduce halides that are stronger reducing agents than the chloride. So basically, when are we going to see? We said that here we have 2 phases. Where are we going to see a change in color? We just said that is going to be, who is going to be oxidized? If the X is either bromide or if it's iodine. So when we look at the color of the mineral oil, has no color. But once you form the halogen is nonpolar. So it's going to be dissolved in the mineral oil. It's not going to be it's not going to stay in the aqueous phase. In the aqueous phase, because it's polar, the salt is going to stay there, but not the halides, not the halogens. So when we look at before we add the chlorine water, the color of the mineral oil is colorless. Then we are going to add the chlorine water. And we said that the fluoride is not going to change. This part is going to be colorless. What is going to happen with the chloride? We are going to see a yellow. Well, a yellow is the color of the Cl2 in the mineral water. What is the color of the of the bromine? The color of the mineral oil becomes red orange, and in the case of if we had the iodine, is going to be purple red. You are going to be given all that data because you are not in the lab doing the experiment. So you are going to be given, and then you will have to say, comparing depending on what your unknown gives, what change in the reaction, then you're going to say, okay, I have bromide or iodine, or it's going to be any of the four. We are testing only four, and your unknown is one of the four. So that's why it's very simple. Any questions here so far? Okay.
I have a question. So basically, we're just basically knowing I guess the principle of this second formula is just to know which one's the oxidizing agent. Then after you have the 5 tubes, then you add the mineral oil. It starts off as colorless, and then after you add the chlorine water, there's going to be a color change, and you're just trying to see which element is causing the color change.
Exactly.
Okay.
If you see in the mineral oil, depending on the color,
yeah,
it's colorless. Exactly. And if you see that you have a red orange, okay, you're gonna say I have bromine.
Okay.
Yeah, if I have a purple red, you're gonna say I have iodine. And if it's colorless, you're gonna say, okay, I have fluor. Yeah, exactly. And but it will be important for you to recognize when you have a redox reaction, who is oxidizing and who is reducing. So you can review that, like in this case. We said that the chlorine water goes from 0 to -1, so the chlorine water is reducing. Yeah, only that.
Okay. No, because you were saying that you're saying it went from bromine to bromide.
From let me see.
When after you add the chlorine water, it gets oxidized, right?
So basically, let's say here I have sodium bromide, and because it's in this is sodium. Let me write it bromide, because sodium bromide. So it is a halide that we are testing. It ends in IDE.
Oh yeah.
And the bromide, the oxidation state is -1. Do you know why? Because, right, how to get the oxidation state? The sodium is group 1 and it has +1. And all the halogens in group 7 have -1. So you look at bromide on the reactant side, and then you look at the same bromide on the product side. If X is bromide, here you are going to have
PR2.
exactly. And this is bromine, a diatomic molecule.
Oh.
And this is in elemental state. So you know that if you have the element, the
It's
oxidation state is 0.
Okay.
Yeah.
Thank you.
You're welcome. So this is basically, here is explaining what I already explained. And because this is in case you are doing it in the lab, but you are going to receive all this information, because all you have to do, I will show you later, is basically say which one is your unknown. So that's why I'm saying that this experiment it's really simple. It's about learning the two reactions, knowing the form, knowing who it oxidizes, and let's do some practice. I have a few just to make sure that we are in the right page. So just to make sure, let's look at the first question. Somebody can read the first question. Who can read the first question, please?
I can.
Thank you.
What is the balance equation for the reaction of halides with chlorine water in the presence of mineral oil?
Exactly. Can you read it? Can you write it? Who can answer that question? We saw, it says, what is the balance? Sorry.
Is it not the second equation?
Yes, exactly.
Okay.
I just trying to review.
Oh,
so
okay.
When,
Okay.
yeah. So when you encounter this, it's easy peasy. So we said the balance equation of the halide with chlorine water in the presence of mineral oil. So basically, you will have to remember X is any halide with chlorine water. You are going to have the chlorine water reduces itself and oxidizes the halogen. And that's why the elemental form of the halogen is not polar. So that's why it is more soluble in the oil layer. And that's why it produces that change in color in the mineral oil. That's all it is. And who can tell me the reaction is going to happen only if the halide is what? If this X is what? When are we going to see a change in color?
When it's lower than chlorine on the periodic table, so it's going to be bromide and iodine.
Correct. And how do you call that? Why is that? How do we call it? Who is a better? The halide has to be what? Lower. But then if it's lower, it's a better reducing agent than chlorine.
Oh, okay.
So that it's so when is this reaction? It's lower. Yes, that's how we are going to remember. But why? Because as you go down in the group in the periodic table, the halide is going to be a better reducing agent than the one on top. Yeah, so basically as we go down in the periodic table, the halogens become stronger reducing agents, which means stronger reducing agents means that they oxidize themselves to elemental form. So that is it's the whole thing. Any questions on oxidizing and reducing and or it's clear? Okay, let's go to the next question. What are the different colors of the mineral oil after adding chlorine water for the 4 halides we are testing? Who remembers fluoride? Fluoride is what?
Colorless.
Yes. Chloride?
Yellow.
Yes. And bromide?
Red, orange.
Awesome. And iodide?
Purple, red.
Awesome. Thank you. Go to the next one. What is the balanced chemical reaction when you mix sodium chloride and silver nitrate solutions? So you have a solution of sodium chloride, and we write AQ because it's a clear solution, and you mix it with silver nitrate that is also a clear solution. Many salts of silver are not soluble, but silver nitrate is a soluble salt. So basically aqueous and aqueous. You have 2 liquids and you mix them. What do you get? You get a solid silver chloride plus
Sodium nitrate.
exactly. Thank you. So if you have the tube here, and you have here the solution of salt, sodium chloride, and you add the liquid, a few drops of, what are you what are you observing if you do this reaction? Here, when we write the balance equation, we know that we have a precipitate because silver chloride is a white solid. We write the S because it's a solid. So what are you going to observe? How do you know you have a solid? By looking at your tube.
You're gonna see a white solid, a precipitate.
Yeah, you're going to see that. And sometimes it's not enough to see the separation of the solid, but you will see a cloudiness.
Oh, okay.
Instead of a clear liquid, you see both of them are proof that you have a solid. If you have enough, yes, you are going to see the separation of the white solid. But sometimes just a cloudiness is a proof that the salt, the insoluble salt, is there. And let's go to number 4. In the following reaction, which species oxidizes and which reduces? Who can tell me that? What is the oxidation state of bromide? We look at the charge, halogens,
Negative
all the
1.
groups. Yes, all the group 7 has -1. And then we look at the bromide on the other side, on the product side. And what do we see? That the bromide is elemental.
0.
Exactly. So it went from a lower number to a higher number. So what happened with the bromide?
It was oxidized.
Exactly. The bromide oxidizes. And what happened with the chlorine water?
It went from 0 to -1, so it gained an electron, so it was reduced.
Exactly. Very good. Very good. That's perfect. So this is something that is not much in this experiment. This is basically it. Be familiar with the two different reactions, and there is not much in this. Do you have any questions about this experiment?
So I think so okay, for the first equation, because I came in late, sorry. So basically what you're doing, you're adding in this ammonia, and then the ammonia is going to cause it to dissolve.
Exactly. So basically, what is happening, let me see if I have it here. Okay, so basically, the second is the chlorine water, and the first one, the first reaction, you have the same 5 tubes, right?
Mm-hmm.
And you are going to add, so you have the halogen, and you are going to add the silver nitrate, that is aqueous. And we know that 3 of the 4 halides will form an insoluble salt. If this is, let's say, chloride, we are going to form a precipitate that is silver chloride.
Okay.
And depending on fluoride, is not going to form a precipitate.
Yeah.
And the color is going to be different. So the silver chloride is going to be white. The silver bromide is going to be a little off-white.
Mm-hmm.
The silver iodide is going to be yellow. And
Okay.
once you have the precipitate, depending on how many drops of ammonia, because the ammonia is going to dissolve the precipitate because it forms that complex. Let's say silver forms with ammonia this complex and dissolves the precipitate. But if you start with this precipitate and you add drops to dissolve, drops of ammonia to dissolve it, you might need 15 drops to dissolve it. But if you have bromide, you need a little more, and for
Mm-hmm.
iodide, you need a little more. That's all it is.
Oh, okay.
And you will see that in the report. And I would say that this is all is a qualitative analysis of just these 4. But before you go, I want to make sure that everybody has Excel. The next experiment is the freezing point depression, and it's more time consuming. You will need to plot data in Excel and find the intersection and do not many calculations, but you can have Excel for free from TCC.
Mm-hmm.
Do you have Excel in your computer?
Yeah.
Okay, great. Everybody has Excel. Awesome, awesome, perfect. Okay, so then I'm fine. And everybody knows how to plot data in Excel. You can practice that. If not, I will go over next time, it might take a little longer to, but I will I will explain how to do, how to plot the data in Excel and how to complete step by step the experiment, because that in the past, that brought a little bit more trouble to the students. So I want to make sure that step by step everybody can do it.
Okay.
Okay, so that's all. Everybody has Excel. That's the best, the first part, and everybody probably. Do you know how to plot data in Excel?
Kind of.
Okay, we'll go over it.
Okay.
And we are going to finish here. If you don't have any more questions, I will stop the recording, but I will stay in case you want to ask me something else. Thank you again.